This collection of problems is about the fundamental theorem for line integrals. The fundamental theorem that we study in calculus say that the integral of f of x d dx is equal from x equal a to x equal b is equal, find the antiderivative f of x and makes this operation f of b minus f of a, and you will obtain the area under the curve from A to B. So in some way the region is, the information of the region is contained in the information of the antiderivative. So the difference f of b minus f of a, the difference of the evaluation of the antiderivative at the point b minus the antiderivative at the point a will give you the area. Wow. But now we'll see something similar for vector fields. What we will see is that when you have a vector field f, if f is conservative, so now is fundamental theorem for line integrals. Now, if f is a conservative field, what it means that f is a conservative is if it exists a function whose gradient of f, a little f, whose gradient is the vector field, then something incredible happens. If you want to find the work, which is the integral of f scalar ddr, now you can find the work by not calculating the work. Why? Because now you will find f, the gradient of f, the gradient of some function scalar ddr. And the gradient scalar ddr and the gradient of f is the derivative of f respect to the xi plus the derivative of f respect to the y j scalar ddr ddxi plus ddyj. But this work is the integral from r equal ra to r equal rb of what? Of this dot product. But what is this product? Is the change in f. So this will be f evaluated at the point v minus f evaluated at the point a. So doing this, we can find difficult integrals that we could have to find the integral over some paths that are difficult. But now we don't need to find the integral. We don't need to do what we have done on the last videos. We can do this. We can do the difference between the potential functions. The f is called the potential function in a way that we find the work done. So this is only valid when f is equal to the gradient of little f, of the potential. When this is happen, we say that this means that f is conservative. So to be conservative means many different things that are all equivalent. For example, it means that the work for going from A to A is 0 because f of A minus f of A will be 0. It means that, for example, that the curve of f is 0. Wow. Why? Well, the curve of f will be the curve of the gradient of f. But the curve of f will be I, j, k derivative respect to the x, derivative respect to the y, derivative, partial derivative respect to the c of the gradient of f. The derivative, the component of the gradient of f are the derivative of f respect to the x, derivative of f respect to the y, and the derivative of f respect to the c. And this will be for one component, the I components will be I derivative, partial derivative respect to the y of the partial derivative of f respect to the z minus partial derivative respect to the c of the partial derivative of f respect to the y. So if f is continuous, this partial derivative, the cross, the derivative of f respect to the y and z will be equal, if f is continuous, is equal to the partial derivative of z respect to the c and to the y. So the second derivative will be the same. So this will be 0. So the curve, and this will happen for all the components, so the curve is 0. So if the curve is 0, the f is conservative. If the f is conservative, f is equal to the gradient of some potential function, some f. If f is conservative, the vector field is conservative, the work from going to A, from A to A is 0. If f is conservative, the work from going to A to B depends only on the final point and the initial points. So everything is very equivalent. So let's go to solve the problem. So the problem say, so we erase here, we don't need this now. The problem say, is this force vector field conservative? Well, to see if it's conservative, we will find the curl of f. If the curl of f is 0, we know that it's conservative. So it will be I, j, and k, derivative respect to the x, derivative respect to the y, derivative respect to the c, and e to the x sine of y, e to the x cosine of y, and 0 because it has 0k components. What is the component I? The component I is minus the partial derivative of y, 0, minus the partial derivative respect to the c of e to the x cosine of y. Because e to the x cosine of y doesn't depend on c, this is 0. So the I component is 0. What will happen to the j component? Well, the j component may be 0, maybe. Okay, the j component is minus the derivative respect to the x of 0, which is 0, minus the partial derivative of e to the x sine of y respect to the y. The derivative respect to the x is j is the derivative 0, the derivative respect to the c is again 0 because this doesn't depend on z. So the j component is 0. So let's go to see the last component, k. The k component would be the derivative respect to the x of e to the x cosine of y minus the derivative respect to the y of e to the x sine of y. If this term is 0, the curl will be 0. So what is the derivative respect to the x of e to the x cosine of y? What is the derivative respect to the y of e to the x sine of y? Is e to the x cosine of y. So all the components are 0, so this vector field is conservative. Let's go to the next problem. Now we have another field that is a little bit more strange, It's in 3 dimensions, and they ask, is conservative? Well, if the curve of f is 0, it's conservative. So what we have to do? Well, we need to calculate the curve of f. If it's 0, it's conservative. We only calculate one component. So is the derivative with respect to the x, the derivative with respect to the y, the partial derivative with respect to the c of the y natural log of c, x natural log of c, x by y divided by c. So let's go to calculate the j component. The j component will be the derivative with respect to the x of xy divided by c minus the partial derivative of x with respect to the c of y by natural log of c. It will be 0 or it will not be 0. So the partial derivative of x multiplied by y divided by c, this is y divided by c minus the partial derivative with respect to the c of y natural log of c is y by the derivative with respect to the c, that is 1 divided by c. Oh, this is 0. So the j component is 0, and you can check the y and the k component, it will be 0. Oh no, maybe no. Let's go to check. Maybe no. So the I components is the derivative with respect to the x. X multiplied by y by c. The I components, sorry. The I components, let's go to check the I components, is the derivative with respect to the y, the partial derivative with respect to the y of xy divided by c minus the partial derivative with respect to the c of x natural log of c. It is 0 or not 0? Okay. The partial derivative of x multiplied by y divided by c, the partial derivative is simple x divided by c. And here the partial derivative of respect to the c, x is constant, so it's the partial derivative of c of natural log of c, which is 1 divided by c. So this is again 0. So the I component is 0, the j component is 0, and the k components, let's go to see the k component, is the derivative, the k component is the derivative respect to the x of what? Of x natural log of c minus the partial derivative of y natural log of c. And if this is 0, we are done. The derivative is natural log of c. And the derivative with respect to y of y natural log of c is natural log of c. So this is 0, so the field is conservative. Let's go to the next one. Evaluate the line integral of this field. Well, of this field, and you go through the ellipse C, and you go from 5, 0 to 0, 4. So this is 5, 0, and this is 0, 4. 0, 4 is here. And you go through a path that is an ellipse. And also, there is a vector field here. For example, at the point 5, 0, the vector field is here. Fx is 2xy. Fy is x squared plus y squared. So at the point 5, 0, x equals 5, y equals 0, the component x is 0. At the point x equals 5, y 0, the component y is 25. It means that at the point 5, 0, there is a vector that is the force vector that has 25 units and is in the j direction, Fy. At this point, 0, 4, the vector field at 0, 4, f of x is equal to 0, f of y, f of y is y squared. Y squared is 16, so the component y is 16, so it will be like this. 16 going up. So at any point of the ellipse, there is a vector field. Vector field, vector field. So you walk through the ellipse and you want to find the work, the integral of f dot ddr. You want to find this integral. And the trick here is to check that this vector field, the vector field f equal 2xyi plus x squared plus y squared j, this vector field is conservative or is not conservative. If it's conservative, we can save to do the calculation by doing something very, very simple, that is to find the potential, to find the function f, little f, whose gradient is f. Let's go first to see if it's conservative or not. Conservative or not conservative. To find if this is conservative, we find only the k components, no need to find the y and the j. So the fx will be 2xy, the fy will be x squared plus y squared, and the c will be 0. So this vector field, the curve of f, will have only k components. And the k component of the vector field will be the derivative, the partial derivative of x squared plus y squared minus the partial derivative respect to y of 2xy. If this is 0, we are done. The partial derivative of x is 2x, the y 0, minus the partial derivative respect to the y of 2xy is 2x, so it's 0. So the curve is 0, so the vector field is conservative. Now we have to find who is the f whose gradient is the vector field. So the gradient is the derivative of respect to the x of f, I plus the derivative of the respect to the y of f, and this should be equal to the vector field, and the vector field is here, is 2xy I plus x squared plus y squared. So it's 2xy in the I direction plus x squared plus y squared j. So we conclude that this vector field is conservative, and now if it's conservative, it always exists a function f whose gradient is the vector field. So what we want to do now is to find who is f. When a vector is equal, when a is equal b, when the components are equal. So the derivative respect to the x of f should be 2xy. And now our question is, who is f? who is the function f whose derivative is 2xy, whose derivative respect to the x is 2xy. Well, x squared plus y, the derivative is 2xy, so it works. F could be x squared plus y, but we need to fit the second condition, that is the derivative of f should be x squared, respect to y should be x squared plus y squared. And now we wonder who is f whose derivative with respect to the y is x squared plus y squared. And the solution is, well, what is the function whose derivative is x squared plus y squared? Well, is x squared plus y cubed divided by 3 will work? Let's go to see. The derivative of f respect to the y here is 0, so it will not work. So I need to put a y. Now the derivative of f respect to the y will be x squared. And now I need to produce a y squared. So the derivative of y cubed divided by 3, the derivative respect to the y, the derivative respect to the y of the f will be 3i cubed, 3i squared divided by 3 will be produced this. So this function will produce the function that we are looking, but which one we will have? Well, this is the common factor. This is the common factor, and if we add this, we are done. So if I choose f of xy equal x squared y plus y cubed 3, I can fit with the two conditions. The first condition say that the partial derivative respect to the x of f should be 2xy. So this is the first condition. And the second condition. So let's go to check it. The partial derivative respect to the x is 2xy. Oh, perfect. Because the partial derivative respect to the x of f, this is 0. And so this is check. And now let's go to do the second condition. The second condition say that the partial derivative in respect to y of f should be x squared plus y squared. Let's go to do it. Respect to the y, the first partial derivative will be x squared plus. And respect to the y, the partial derivative is 3y squared divided by 3 is y squared. Done. Check. So finally, this is the potential. This is the function whose gradient gives the vector field. Okay? And now that we have the gradient, what we will do? We will use our theorem for line integrals that say that the integral of f scalar ddr, if f comes from the gradient of some potential, so if f is conservative, meaning that f is the gradient of f, so this will be the integral of the gradient of f scalar ddr, it will be the integral of ddf. So it will be f of b minus f of a. And who is f of b? Well, the function f of xy is x squared plus x squared plus y cubed divided by 3. So I need to evaluate this function at 2 points. What are the points? The point where the 5, 0 and the 0, 4. 5, 0 and 0, 4. 5, 0 and 0, 4. So it will be equal f of 5, 0 minus f of 0, 4. What is the value of the function at the point x equal 5 is 5 squared, but this is 0. And y cubed, this is 0, so it's 0, 0 minus f of 0, 4. When x is 0, this is 0. When y is y cubed divided by 3. So 4 cubed divided by 3, so the line integral is 4 by 4, 16, 16 by 4 divided by 3, or 6 by 4 is 24, 4 by 1, 64 divided by 2, or 30, 32. 32 is the answer. So what we have done exactly? Well, we didn't do the line integral. What we have done is to check first that this vector field is conservative. This is the vector field. Once that we know that it's a vector field, we know that exists the potential, the function whose gradient is the vector field, and we have found the potential, so we only do f of final 0, 4 minus f of 5, 0. F of 0, f of 0, 4 minus f of 5, 0. Let's go through if I did this thing. F of 5, okay. So the work is 32 and the work is positive. It means that the mass, the object, will absorb this energy. You transfer the energy of 32 units, 32 joules, to the object. And this energy becomes kinetic energy. The 32 joules appear as an increase in the kinetic energy. Okay, let's go to the next problem. I'm sorry, this is a 3. I made a mistake. This is 3, and this is 3. So this is not 32. It's 64 between 3. Divided by 3 is not 32. It's 20, 21, 25, right? I said 21, 25, 21, 42, 63, 21, 33, 33, 21, 33. Okay, let's go to the next problem. Well, the next problem is very similar as the last one. It's only that that now you go through the parabola, but indeed it doesn't matter from which path you go, because the vector field is the same vector field and is dependent of the trajectory, dependent on the path. It depends only on the initial and final points. So from this vector field, f equal 2xy I plus x squared plus y squared j, we already found the potential, the function whose gradient is the vector field. And this we said that is x squared plus y, x squared multiplied by y, plus y cubed divided by 3. So what we have to do to find f scalar DDR from the point 2, 0 to the point 0, 4? Well, do f of 0, 4 minus f of 2, 0, and you will obtain the result. And what is f of 0, 4? Is x squared plus y will be 0, plus y cubed plus 4 cubed divided by 3, minus f of 2, 0. f of 2, 0 is 0, because 2 is here, but y is 0. So this is 0, and this is 0, is 0. So the total result will be 4 cubed divided by 3. So it's 16 by 4 divided by 3, or 24, 64 divided by 3, or 21 something. 21, 21, 21, 63, 21, 20, 21, 33. Oh, this is the result. It's the same result that last problem, but indeed what we is a coincidence. Because there are 2 points, there are 2 different points on this problem that on the last problem. not necessary, should be the same work done. So the work done is 21.33, and so the work done from going to 2-0, the work is 21.33, and I didn't calculate any line integral. Wow. Let's go to the next problem. Next problem say, this is evaluate the line integral. So the first thing that we have to do is what? To check is the vector field is conservative. What is the vector field? The vector field is y by ci plus x multiplied by cj plus xyk. Is this vector field conservative? So we make the curve of f. And the curve of f is yjk, yz, xc, the derivative respect to the x, the partial derivative respect to the y, the partial derivative respect to the c, yc, xc, xy, and let's go to see if this is conservative. So the y components will be the derivative respect to the y of x multiplied by y minus the derivative respect to the c of x multiplied by c. So the derivative respect to the y of x multiplied by y is x, and the derivative respect to the c of x multiplied by c is x, so this is 0. I suspect that the j and the k component are 0, but we need to be sure. So the j component is the derivative respect to the x of x multiplied by y minus the derivative respect to the c of y multiplied by c. The first derivative is y, and the second derivative is y is also 0. And the k components, this you have a minus sign, doesn't matter because it's 0. The k component is the derivative respect to the x of x multiplied by c minus the derivative respect to the y of y multiplied by c. And what is this derivative? The derivative respect to the x of x multiplied by c is c. And the derivative respect to the y of y multiplied by c is also c. So this is 0, so the vector is conservative. So if the vector is conservative, forget about this information, no need. No need information about the trajectory or the vector value function. Just we need the initial and the final point. And what are, well, we need a little bit of this information. What are the initial point? The initial points, because the x is the t, the y is the 2, and the c is the t. When t equals 0, the point is 0 to 0. So when t equals 4, what will be the point? The point will be, when t equals 4, the x will be 4, the y will be 2, the x will be 4. So we go from the point 0, 2, 0 to the point 4 to 4. And now we can find for this vector field the potential and evaluate the potential between final points and initial points. So let's go to find the potential now. So the vector v, the vector field is this one. Let's go to write it here. yc, the vector field f is equal yc I plus xcj plus xyk. And we want to find a function, a potential function f, whose gradient is the vector field. So we want to accomplish this equation. So two vectors are equal when the components are equal. So the y by c is the derivative of f respect to the x. So we wonder, who is f? Who is a function whose derivative of f? Well, y by c by x, the derivative. Of course, if I add here another function, let's say phi1 of y and c, the derivative, the partial derivative respect to the x will be 0, and I am also okay. So the first condition is this one, that this component equal to this component. The second condition is that x by c will be the partial derivative of f respect to the y. And who will be f? F will be the function whose derivative is x by, whose derivative respect to the y will be x by c. So xc by y, the derivative xc, and maybe I can add phi2 of, I do the derivative x and z. So if I make a derivative of a function that depends on x and c, respect to the y, the derivative will be 0. So the third thing that I can do, the third condition will be that x multiplied by y should be the derivative of f respect to the c. So the f is clearly x by y by c. So in every case, of course, I can add, if you want, phi of x, y. Because the derivative respect to the c of any function that depends on x, y will be 0. So who is the f? Well, in every case, the f is x, y, c. So we don't need to play with these functions, I suppose. Let's go to try. So we say the f of yc is x multiplied by y multiplied by c, and the gradient of f should be the vector field. So what is the derivative of f with respect to the x? Is yc, I. What is the derivative of f with respect to the y? xc, j. What is the derivative of f with respect to the c? xy, k. And who is the vector field? Well, the vector field is this one. It should be the same one. ayc is here. The vector field is the same one. Okay. So we have the same, we produce the same vector field. So now we need to do the work. The work of f scalar ddr will be, now that we know who is the f, will be f of b minus f of a. Who is the point b? The point b, according to the problem, is the point b is the point 4 to 4 and 0 to 0. 4 to 4, 4 to 4, f of 4 to 4 minus f of the point 0. What is the point a?
0.
0 to 0, 0 to 0. F of 0 to 0. And who is the function? This is the product. 4 by 2 by 4 minus 0, because it has a 0. Yeah, it will be f of this function is x by y by c is 0. 4 by 4 is 16, is 32. So the result is that the work from going from point A to point B is 32, and we have saved the big problem to do the line integral. Okay, now we are going to do the same problem basically. Who is the potential? The potential is f of x, y, c, x multiplied by y multiplied by c. It's the same. But now the problem say that the curve C, you have to travel from point A to point B. The point A, who is the point A? The point A is when t equals 0. And when t equals 0, the x is 0. The y is 0. And the c is 0. So the point A is the point 0, 0, 0. And who is the point B? The point B is when t equals 2. When t equals to the x is 2 squared. So it's 4. The y is 2. And the c is 4. And what is asking the problem? Make the line integral of f scalar ddr. Who is f? F is yci plus xcj plus xyk. So what is the line integral from going from the point A to the point B? Well, f of b minus f of a. Who is f of b? Well, is f of the point B. And the point B is 4, 2, 4. Minus f of the point A. And the point A is the point 0, 0, 0. And what is the f of 2? Is 4 by 2 by 4. Minus 0 by 0 by 0. And what is that? Is 462 is 32. 32 units is the work done without doing any calculation for the line integral. Just using the theorem, the fundamental theorem for line integrals. What it means that? It means that if you go from point 0, 0, 0 to the point 4, 2, 4, let's say here in space, no? At this point in space, 4, 2, 4. Wherever you go, whatever the path that you choose to go, the work will be the same. Wow! Whatever the path that you choose, if you choose this path, the work will be 4 even if you choose a direct path. The work will be always 4 because the vector field is conservative. Okay, next problem. Now let's go to similar problem. Now the vector function, the vector field, is cosine of x sine of y I plus sine of x cosine of y j. This is the vector function, the vector field. We want to see first if we expect, we need to find where c is the line segment from 0 to minus pi. Well, there is a line segment that connects the point 0 minus pi and 3 pi divided by 2 by pi divided by 2. So we can do it directly, or we can use the theorem of line integral, theorem for line integrals, but we need to be sure that this vector field is conservative. So we need to be sure that the curl of f is 0. So how we will be sure? Well, we will calculate sine of x is the derivative respect to the x, the derivative respect to the y, the derivative respect to the c, cosine of x sine of y, sine of x, cosine of y, 0. And the k components, that is the one that we need to find to be if it's 0, is the derivative respect to the x of sine of x, cosine of y, minus the derivative respect to the y, partial derivative of cosine of x, sine of y. And what is the partial derivative of x respect to the x is cosine of y. The derivative of sine of x is cosine of x, perfect, minus the partial derivative respect to the y of sine of y is minus cosine of y by cosine of x. Minus minus is plus, so this is not conservative. Let me check. So it's the derivative respect to the x of sine of x cosine of y. Perfect. In the derivative respect to the y of cosine of x sine of y. Perfect. The derivative respect to the f of sine of x is cosine of x. Oh, sorry. Yeah, I did a mistake. Oh, is cosine of x is written here, cosine of x. Also, sorry, no, it's not. Well done. The derivative respect to the x is cosine of x by cosine of y, that is a constant. Okay. Now, the derivative respect to the y of sine of y is cosine of y, plus it's positive, multiplied by the constant cosine of x, that it will be treated like a constant, and this is zero. This is zero. Okay, so I can apply the line integral theorem, the first theorem for line integrals in this. Also, but who is f? Who is f? Who is f? Who is the function f, the potential whose radian is the f? Who is the function whose derivative respect to the x of fi plus the derivative of f respect to the yj is the f? And the f is cosine of x sine y I plus sine of x cosine of y j. Who is f whose derivative respect to the x is cosine of x sine of y? Well, I would say that f of xy should be a function whose derivative respect to the x, partial derivative, should be cosine of x sine of y, so sine of x sine of y will work because now the derivative of sine of x will be cosine of x. Perfect. Now the second condition should be that the derivative, the partial derivative of f respect to the y is sine of x cosine of y. Who is f of xy? Well, here I can add a function that depends on y, so the partial derivative respect to the x will be zero in any way. And now, who is the function whose derivative respect to the y will be sine of x cosine of y, so it will be sine of x sine of y, the derivative of sine is cosine. Perfect. So this is the and this is of course must phi of x, you know, but we don't need to add it. We find who is the potential function. The potential function f of xy is sine of x multiplied by sine of y. Whatever we choose here, when we subtract the numbers, when we subtract the value of the function, will cancel. So, no problem. So what will be the work? What will be the integral of this vector field without doing any calculation? It will be f of b minus f of a. What is the point b? The point b is 0, minus pi and 3 pi over 2, 3 pi pi. 3 pi, 0, minus pi and 3 pi over 2, what? Pi over 2 minus f of 0, pi, I don't remember. 0, minus pi. Minus f of 0, minus pi. Or in other words, sine of 3 pi divided by 2 multiplied by sine of pi divided by 2 minus sine of 0 multiplied by sine of minus y. Well, minus pi. Well, sine of minus pi and sine of 0, this is 0. And sine of 3 pi divided by 2, this is minus 1. And sine of pi divided by 2 is 1. So the total work is 1. 1 joules of work is done when you move, when the force is being moved. Well, there is, we have to be careful because there is a minus sign here in physics because the force is minus the gradient of f. So we need to be careful now. But the calculation is here is 1. The line integral, the value of the line integral is 1. 1 or minus 1? Minus 1, minus 1. Okay, the problem is done. So to find this, the solution to this problem is exactly, again, the same thing. We need, is conservative. Okay, you see if the curve of f is 0. What is the potential function f of x, y? What is the function whose derivative respect to the x and gives 2x? Who is the function whose derivative respect to the x is 2x divided by y? And who is the function whose derivative respect to the y is minus x squared divided by y squared? Well, from the first one, I would say that I need to find a function whose derivative is 2x divided by y. So I will do 2x squared divided by y, 1/2, and now 1/2, so x squared divided by y. So x squared divided by y will work to make the partial derivative of f to be this. And the f for this condition, it will be the same. It will be x squared divided by y, because when I make the partial derivative of this function respect to y, it will be x squared. The derivative of y minus 2, y minus 1 will be minus y squared. So this function will work as a potential function. So I need to do the work done by this force from going from the point minus 1 to the point 3,2. So the work by going from the point minus 1, to the point 3,2 of the integral of f dot dr. So usually you put the initial point here and the final point here. So is f of 3,2 minus f of 1,1. And what is f of 3,2 is 3 squared divided by 2. Minus f of 1,1 is 1 squared divided by 1. So it's 9/2 minus 1 minus 2 divided by 2 is 7/2. So this is the result. And the problem is done. Now let's go to do the last problem. And it say, check if this is conservative. Well, we can check. It's easy to check. It's yjk partial respect to the x, partial respect to the y, and partial respect to the c of y divided by x squared plus y squared, and minus x divided by x squared plus y squared, and 0. So we check only the k components. So the k components will be the partial respect to the x of minus x divided by x squared plus y squared, minus the partial respect to the y of y divided by x squared plus y squared. If this is 0, the field is conservative. So what is the partial respect to the x? So this is minus x multiplied by x squared plus y squared minus 1. What is the partial respect to the x? Is the derivative of the first by the second, the first by the second, plus the first by the derivative of the second. That is x squared plus y squared minus 2. And if we do the same thing with the partial respect to the y, we'll obtain the same result. We'll obtain the same result. Let me check. So this is the partial respect to the x of this expression. And the partial respect to the y of this expression, y, is the partial respect to the y of the expression y, x squared plus y squared minus 1, which is the derivative of the first is 1, x squared plus y squared minus 1, plus y multiplied by the derivative, minus 1, x squared plus y squared minus 2, and 2y. And 2y here, and here is 2x. Now let's go to see what it say. It will be, here it will be minus 1 divided by x squared plus y squared. Plus minus minus is plus x divided by multiplied by 2, and by x is 2x squared, and we'll go in the denominator x squared plus y squared squared. And here we will have 1 divided by x squared plus y squared. And here we have a minus sign, the y, the 2, the y squared, and in the denominator y squared plus y squared squared. Let me see. And this term cancel with this term. And this term does not cancel with this term. Let me think. 2x squared minus 2y squared. And these are two different terms. So this is not conservative. Let me think. Let me think on the signs. Let's go to see the signs. Minus minus is plus 2x squared. 2x squared and 2y squared. So this field is not conservative. Wow. We need to do it. I see now. It's conservative because it's minus 1 divided by x squared plus y squared. I'm copying from here. Plus 2x squared divided by x squared plus y squared squared. Minus, I'm copying from here, minus 1 divided by x squared plus y squared minus 2 times y squared divided by x squared plus y squared squared. So it will be minus 1 minus 2 divided by x squared plus y squared plus 2 times x squared minus y squared divided, here is a plus or is a minus? Here is a minus, but is minus the second, so this is a plus. So this is plus. So it's 2 times x squared, exactly, divided by x squared plus y squared square. So it's minus 2 times x squared plus y squared plus 2 times x squared plus y squared. This is 0. So the field is conservative. So if the field is conservative and you go around the circle of radius 1, the circle doesn't contain the origin, so there is no problem. So if you do around the circle and you go one round, the work will be from A to A. So the work will be 0, because I don't need to find the potential function f of xy. I don't need to find this potential function. The work will be 0. And this is, let's go to connect a little bit more with the physics. So in physics, this is the treatment that we do. The work is the same, is the force scalar ddr. And the work is also f of x ddx plus f of y ddy. And now, the works, if f is conservative, if the force is conservative, it will exist f whose gradient is the force. But now in physics, the force is pointing in the opposite direction as the gradient. So the gradient is pointing in the direction of maximum increase of the function. Now the force is pointing in the direction of maximum decrease of the function. That's why in physics we write f as minus the gradient of the potential. So let's go to see what it means, this. The work done by a force is the integral of fx by ddx plus fy by ddy plus fc by ddc. And if the force is minus the gradient of a potential function, let's go to the right here, the force is minus the gradient of e sub p of x comma y, or minus the gradient of e sub p of x comma y. If the force is minus the gradient, I can do this calculation using the theorem for line, the theorem for line integral. This will be e sub p of a initial minus E sub P of B. So in other words, the work is minus the change in the potential energy. And we see in other videos that also the work is the change in the kinetic energy. Oh, so if we have conservative forces, what we have is that the change in the kinetic energy, E sub k at B minus E sub k at the point A is equal to minus the change in potential energy, E sub P of B minus E sub P of A. So, E sub k of B plus E sub P of B will be equal E sub k of A plus E sub P of A. From this statement, we can go to this statement. And this is called the total energy, total mechanical energy at the point V is equal to the total mechanical energy, kinetic plus potential at the point A. So the energy is conserved, and this is the principle of conservation of energy that takes place only when F is conservative. Now let's go to write a little bit more of the physics involved in line integrals. We say that the small work done by a force is f of x ddx plus f of y ddy plus f of c ddc. And we have said that if f is conservative, this is minus the small change in the potential energy. But the small change in the potential energy is minus the partial derivative of E sub P respect to dx by ddx plus the partial derivative of E sub P respect to the y by tdy plus the partial derivative of E sub P respect to the c by ddc. From here we have three relations. The component x of the force is minus the partial derivative of E sub P respect to the x. The component y of the force is minus the partial derivative of E sub P respect to the y, and the component c of the force, the c components, is minus the partial derivative of E sub P respect to the c. And these are the equations that govern the physics where the forces are conservative. So let's go to do one example. Let's go to consider two dimensions, but in order not to write too much. Let's consider a force that is a central force. So let's say electrical force. Electrical force go K, Q1, Q2. So you have two charges, Q1 and Q2, and between them there is an interaction, there is a force. So Q1 will act on Q2 and will exert a force. The force can be attractive or can be repulsive. And the force depends on the distance r squared that separation. So the force is inversely proportional to r squared. And the force is pointing in the r direction. The force acting on Q2 due to Q1 is on the vector r, on the directional vector r, on the unitary vector r. So this is the force. So now let's go to put it in Cartesian coordinates. The force will be K, Q1, Q2, R squared will be X squared plus Y squared raised to the power 1, and the vector R will be the position vector R divided by his magnitude. So we are thinking that the origin is at Q1. And the vector R is the vector xi plus yj. And the magnitude of R is x squared plus y squared 1/2. So the force, the expression for the force is K Q1 Q2 divided by x squared plus y squared 3/2. 1 plus 1, 1/2 is 3/2, xi plus yj. So this is the force, that electrical force that is acting on Q2 due to Q1. Due to Q1, I'm acting. And now imagine that I have this force, and I ask, what is the potential energy? And what sense does it has to wonder about the potential energy? We'll look now. Now what happened? Now, the component x of the force, now we want to answer, what is the potential energy? First question. Second question that we want to ask is, what for? What for do we need the potential energy? And third question will be, what is energy? Oh, three questions. Let's go to see if we can answer. So, let's go to answer the first question, that is, what is the potential energy? So we have that the component x is K Q1 Q2 multiplied by x divided by x squared plus y squared 3/2. And we wonder who is E sub p, whose derivative respect to the x is this expression. So it's the same game that we have been playing before. So who is E sub p? So E sub p of x of y will be a function whose partial derivative respect to the x will be x divided by x squared plus y squared 3/2. So the function clearly is k q1 q2 divided by x squared plus y squared 1/2. Why? Because if I made the partial derivative of e respect to the x, I will obtain this expression. You see, it's 1/2. The 1/2 is minus 1/2 in the numerator, minus 1/2 x squared to x. The x will appear, minus 1/2. Minus 1 is 3/2, so this is the correct expression. If I do it with f sub y, I will obtain the same potential function. So if I wonder, giving f sub y equal k q1 q2 y divide, you see, y divide by x squared plus y squared 3/2. And I wonder who is the potential function whose minus derivative of e sub p respect to the y will give this expression. And the answer is the same one, this one. Okay, let's go to do it. Minus the derivative of e sub p should be f of y. the derivative of E sub p respect to the y minus the derivative respect to the y of E sub p of k q1 q2 multiplied by x squared plus y squared minus 1/2. It will be equal to minus k q1 q2 minus 1/2, so plus 1/2, x squared plus y squared minus 1/2 minus 1 minus 3/2 by 2x. The 2 will cancel, and I will have that minus the partial derivative is f, sorry, I'm doing the partial derivative respect to the y, to y, and f sub y. F sub y is k q1 q2 divided by y divided by x squared plus y squared 3/2. Perfect. So, and what? Well, I have the potential function. Now I can do the work. Now I can apply the first theorem for line integrals. I can say that the work done by a force, the work done by a force from going from A to B, from point A to B, is simple E sub P of A minus E sub P of B. So, is equal minus the change in the potential energy, because the change in the potential energy is E sub P of P minus E sub P of A. But I'm writing E sub P of A minus E sub P of B. So it's minus the change. Now I can do something else. I can say we have seen in the last video a proof of the theorem of work and kinetic energy. What we have said is that the work of the force produce a change in the kinetic energy. So, because the work is the same work, it means that the variation, the change in the potential energy, is plus the change in the kinetic energy. Oh, what it means that? It means that minus E sub P of B minus E sub P of A is equal E sub K of B minus E sub K of A. So reordering this, it say that E sub P of A, the potential energy at the point A, this term, plus the kinetic energy at the point A is equal to minus plus the potential energy at the point B plus the kinetic energy at the point B. And this is called the principle of conservation of energy, that say the total energy at the point A, the kinetic plus the potential, is conserved, is the total energy at the point B if the force is conservative. So what we are doing here is this game that is very interesting. Imagine that I start with some amount of kinetic energy. Now, imagine that I do a work, a positive work. If I do a positive work, the kinetic energy will increase, and the work done will be seen as kinetic energy. So this is the kinetic energy at A. I did the work, and this is the kinetic energy at B that will appear. Now, what happened with the potential energy? The potential energy, let's say that was a small amount. It doesn't matter what is the amount. Now, what is say the theorem of conservation of energy is that the amount that he has increased, this is the change in the kinetic energy, is the same amount that he has decreased for the potential energy. So the potential energy will be whatever it was, it will decrease in this amount. So the potential energy will be like this. And always the sum will be constant. So you start with this amount of potential energy. A, kinetic energy, this amount, and potential energy. So the total energy will be the sum. This plus this. So this is the total energy at the point A. Now the point B, see what happened. The kinetic energy has increased. Now the kinetic energy is all of this because I have done work. So the kinetic energy is like this. But the potential energy is like this. And the sum is the total energy and have not changed. Wow. So it's like having two accounts, like having two banks accounts. One bank account for kinetic energy, one bank account for